So this is our second lesson in rational expressions. So we want to recall that a rational expression is a fraction where the numerator and or the denominator is a polynomial. We simplify rational expressions by writing polynomials as a product of their factors. Because we talked about yesterday how if they have common factors in the top and the bottom, then we can cancel those. If it's not something like 5x divided by x, where x is a factor in both and we can just cancel those, we have a polynomial that's a quadratic on the bottom or the top, for example, we're going to have to factor it. So the first thing that we're going to do is practice our factoring. So this first one, we have a trinomial, x squared, x's, and constants. Because we have an a value of 1, so remember a trinomial generally we're going to write in the form ax squared plus bx plus c. When a is 1, this is our easiest factoring situation. When a is 1, the only way that we can get an x squared there is if we just have an x times an x. That is going to make it easier because whatever the two numbers here are, they have to multiply to positive 9 and add to negative 6. We don't have to worry about the foiling having to do with a coefficient on an x and the number here. So we just need two numbers that multiply to negative 9 and add to multiply to positive 9 and add to negative 6. If they multiply it to a positive but add to a negative, that means that they both must be negative. And then for 9, 3, and 3 work, and those two add together to 6. Our next one here is a difference of squares. So if you want to write that for yourself, this is a difference of squares, meaning we've only got two terms this time. One's an x squared and one's a constant in this case. But what's special about this is that they're both perfectly square rootables. They're both perfect squares. So x squared, the root of that is x, and 81, the root of that is 9. So what we're going to do is we're going to take the square root of the first one, so x, and that's going to be our first term in both binomials. Then we're going to square root the second one, so 9. That's going to be our second term in both binomials. The difference of squares requires that one be a minus and one be a plus. When we think about this foiling back out, we've got x times x, there's our x squared, negative 9x and positive 9x, those guys cancel out, which is why there's no x term in the middle of this. And then 9 times 9, or negative 9 times 9 is negative 81. This next one, we have 2x squared minus 5xy. So this one's not a quadratic. So we're just looking, can we get any common factors out of this? So we've got an x in both of these terms that we can pull out. So then we have a 2x left and a minus 5y left. This one, we've got a quadratic where our a value, so here, is not equal to 1. So this is the more complex case where we need to go through that little process where we say, okay, I need two numbers that multiply to the product of whatever a and c are. So 3 times negative 16 is negative 48. They need to multiply to that, and they need to add to negative 8. So if I think of factors of 48, I have 6 and 8, but that's not going to add. I have 12 and 4. So 12 and 4, if I make negative 12 and positive 4, that's going to add to negative 8 and multiply to negative 48. So what we do with this, it's not x minus 12 and x plus 4, which is what a lot of people think. We have to split this negative 8x into these two things. It's going to be 3x squared minus 12x plus 4x minus 16. So the big thing here is that we aren't allowed to change the equation. We're only allowed to make it look different. So numerically, negative 12x and plus 4x are still the same thing, but we've just changed the way that it looks. They would add back to that negative 8. Then what we do is we just consider the first two by themselves, so 3x squared and negative 12x, and we look at, can we pull out any common factors here? So I can definitely pull out a 3 and an x. What's left over here is an x, and then what's left over here is a -4. Then I look at just the other two, so plus 4x and -16. I can pull out a +4, and then I'm left with an x and a -4. What's important here is that my x minus 4's now match. Okay, so I have 3x times x minus 4, and I have 4 times x minus 4. These two terms become one binomial, and then the matching one that I have in brackets is the other binomial. So that's the factored form of this. And remember to check factoring, you can always FOIL back out. So you can always FOIL back out to check. This one, really similar. We've got an a value that is not 1. So we have to go through this process again. So we're going to do 4 times 12. So two numbers need to add to 60. And then, multiply to 60, and they need to add to -19. So factors of 60, we've got 6 and 10, but that's not going to work. 5 and 12, but that's not going to work. 4 and 15. And if they're both negative, so I'm going to do -15, -4, -15, -4. If they're both negative, those two fit those rules. So again, I'm going to split my -19x's into -15x and -4x. And then add 12 still. So I haven't changed the numerical value of this. I haven't changed -15x and -4x are still -19x. It just looks different. Now I can say, okay, what can I pull out of each of these pairs? So I have 5x squared and -15x. I can pull out a 5 and, I can pull out an x. So then left over in the first term is an x. Left over in the second term is a -3. Then in the second one, if I have this, I can pull out either a 4 or a -4. Now, if I know that what's left over needs to match x minus 3, if I pull out a -4, then I'm left with x, and then 12 divided by -4, I'm left with -3. If I pulled out a positive, it would have been -x plus 3, and it wouldn't have quite matched. So it's important that I pulled out that negative. If it took you an extra step to get there, that's totally okay. So then 5x minus 4 is one of my factors, and x minus 3 is my other factor. This last one here, it looks like the difference of squares. 4x squared is perfectly square rootable. It's a perfect square, but 196 is not. Okay, so what we want to look at is there a common factor that we can pull out of here? So both of these numbers are divisible by 4. 196 divided by 4 is 49. So now we have a 4 on the outside and then x squared minus 49. This is a difference of squares, right? X squared, the square root is x. 49, the square root is 7. So we're going to leave the 4 out in front. We have x plus 7 and x minus 7 as our two factors that still get multiplied with a factor of 4. We can't just get rid of it. So now that we've practiced factoring, we're going to actually do some simplifying rational expressions with it. So remember how we could simplify a rational number by writing both the numerator and the denominator as the product of their factors. We're going to apply the same thinking when we simplify rational expressions. So first thing that we always have to do here is we always have to factor. So on the top, we just have an a value of 1. So it's going to be x times x. We need two numbers that multiply to positive 20 and add to positive 9. So positive 4 and positive 5 work. On the bottom, same deal, we have an a value of 1. So it's just going to be x times x. And we need two numbers that multiply to 25 and add to 10. So 5 and 5. Okay. Before we start canceling anything, it's really important that we do our NPVs here. Okay, so NPVs we want to do before we cancel so that we make sure that we get every term before it cancels. Both of these terms, so we have x plus 5 cannot equal 0 in both of the terms on the bottom. Okay, so we only actually are going to have one NPV on this one. So if we subtract 5 from both sides, we have x cannot equal negative 5. Then we can cancel the ones that are on the top and the bottom that are the same. So we're left with x plus 4 over x plus 5, and we need to write as part of our simplified expression that x cannot equal negative 5. Our next one, so we've got 1 minus x on the top, that's already factored, and then x squared minus 1 on the bottom. So x squared minus 1 is that difference of squares. The square root of x squared is x, and the square root of 1 is 1. So this is equal to 1 minus x over, got x, and then a plus 1 and a minus 1. So this one looks pretty similar. So we've got a 1 minus x, and then an x plus 1 and an x minus 1. So they all look really similar, but none of them actually cancel quite yet. So if we notice on this one, we have a positive 1 and a negative x, okay, which is opposite of this one. It's a positive x and a negative 1. So if I factor out a negative 1 from the top, so if I pull out a negative 1 from the top, 1 divided by negative 1 is negative 1, and then negative x divided by negative 1 is positive x. And then that stays. So now if I look at it, I have negative 1 plus x, which is the same, it's just in a different order as the x minus 1, right? We have positive x's and negative 1's. So these two can actually cancel. They are the same factor even though they're in slightly different order. We could rearrange this one if we wanted to. So then what we're left with is negative 1 over x plus 1. Now what I forgot to do is my NPVs before I canceled. Oops. So x plus 1 cannot equal 0, so x cannot equal negative 1. And then x minus 1 cannot equal 0, so x cannot equal positive 1. And again, it's really important that we include that in our answer. So x cannot equal, when we have a positive and negative of the same value, you can sometimes see it written as plus or minus 1 like that. So it's x cannot equal plus 1 or x cannot equal negative 1. Our last one here, so 2x divided by x squared minus x. So again, the factoring is a little bit different here. It's not a trinomial where we're looking for two binomials. We can just look at, okay, is there anything common? We have an x and an x in both terms, so I can say, okay, this is equal to 2x divided by, if I factor an x out, I've got x minus 1 left over. Okay, and from here, we're going to do our NPVs before we cancel stuff out. So if x is equal to 0, that's a problem because that whole denominator would equal 0. Or if x minus 1 equals 0, that's a problem. So then x cannot equal positive 1. Then we can look back at this thing and say, okay, we've got 2 times x divided by x and x minus 1. So the x's are common to both the top and the bottom, and we want to cancel out the x's that are by themselves as factors. We can't cancel this one because it's part of a bigger group factor. Okay, so we're going to leave this as 2 over x minus 1, where x cannot equal 0 or 1. Okay, so the key point from today is non-permissible values must be determined before we simplify the expression. It's okay if you forget sometimes, that happens, I did up here, but you have to go back before we canceled stuff out and do our NPVs. Okay, so it's really important that those NPVs get dealt with before the end, whether we're going back and doing it or we're doing it kind of as we reach that step. If you guys look at your outline sheet that I gave you, you'll see the snap practice for today. And if you have any questions, just let me know.